Okay, guys, we're going to do a quick video to help you out here for our exam tomorrow to make sure we're uh, comfortable and ready to roll and ready to succeed in this thing and make 100. So, a couple of things I'm going to do in this video. I'm going to go over a couple of the problems on the worksheet that I'm going to post in Schoology tonight as a review. But before we do that, I'm going to go over a couple of the oxidation numbers involving the transition metal. So I know that a couple of you were a little uneasy with that today. So I'm going to start with that. So you got to know your polys, guys. You've got to know your polys. You have to, because this involves the charge on the poly. If you don't know the charge on the poly or you can't recognize the poly, you're going to be in trouble. You're not going to know what to do as far as your oxidation numbers. I mean, you look on the periodic table and you see there are several oxidation numbers listed for these transition metals because they're variant. They don't have one solid oxidation number. They don't have one solid number of electrons they give up. So you've got to know your polys. You got to be able to identify them, and then you got to know the charge on them. And I'm going to show you how to work with it. As long as you're good on those things, then you should be good with this. So I'm just going to pick a transition metal here. I'm just going to go with cobalt. All right, and then I'm going to throw poly on there. So let's go 4. Okay, so now we have this right here. If we were trying to assign oxidation numbers for this, we would need to first identify this as a poly as being phosphate, and we would then have to identify cobalt as being a transition metal. And then the relationship between those two things, we could come together and we could get the right numbers. So then we got to know the charge on phosphate. And so that's -3. The reason it's not shown there is because it's being balanced by cobalt. So when you get into this scenario of, okay, I've got poly and I've got a transition metal, then you have got to do kind of a two-part thing here. First, treat this poly as one unit. Okay, so we treat it as one unit. So if we bring this down and we say, okay, here's cobalt, and then we have this phosphate right here. We know the phosphate has a 3 negative charge. So we have to balance that. We have to make it to where this whole compound, when it comes together, does not have a charge, which is how it's represented right here. So the only way to do that is to give cobalt a 3 positive charge. Okay, so we now, once we have done that, we now have our oxidation number for cobalt. So now we can throw it up here on cobalt. So now we know it's going to be that +3 right there. And remember, oxidation number is plus before the number, and then our charges, we're putting that number first, then charge. That's the difference here. Okay, so I'm going to erase that for now. And now we're going to go back and continue to assign our oxidation numbers like we have already been doing. So now we're going to give everybody some space. Cobalt, phosphorus, oxygen, no charge, so it's going to be equal to 0. All right, so we know this is going to have a 3 positive charge, and there's only one of them, so 3 times 1 is going to give us 3. We know oxygen is a 2 negative charge, so 2 negative, multiply that by 4, since there's 4 atoms of that oxygen, and that's going to give us -8. Okay, that leaves us phosphorus to be our buffer. It allows us to make this equation true. This has got to equal 0 to make it true, as it is 0 on the right side. There's only one of them, so if we have -8 plus +3, that's a -5, so we need to get another 5, so that'll be 5 right there, times 1 to bring us the 5 right there. Okay, so +8 plus the -8 is going to equate to 0. Don't forget, a lot of people forget there, you got to remember you have to divide by your subscript at the end to get the proper oxidation number. So we have 4 atoms there, so we're going to divide by 4, and that's of course going to be your -2. That's just 1, so dividing these both by 1 is not going to change anything. That's going to be +5. So there we have it. So you follow that every time. So you're going to be in trouble if you don't know your charge on your poly. So again, we've been doing this for a while. Make sure that you're good on that. All right, let me put another one up here, and you can pause the video and try to do this one on your own. Let's see. Okay, go ahead and pause it and try to do it on your own. Okay, so we have nickel being a transition metal, and we have carbonate. All right, so we've got to recognize that as carbonate. So if we separate these two, then we have nickel over here, and we have to make sure that we balance our carbonate, which has a 2 negative charge. So simple enough. If this is 2 negative, we've got to balance that to 0 with this one, which would make our nickel 2 positive. All right, we're balanced. So now we have our nickel oxidation number. So we can go ahead and throw that up there as +2. And now we can work through the rest of this problem the usual way. So nickel plus carbon plus oxygen is going to equate to 0 because there's no charge. So we'll bring this down. Down. All right, we know that nickel is going to be the 2 plus. There's only one of them, so that's going to be 2 times 1, which is going to give us 2. Oxygen, again, -2 times 3, which is going to give us -6. Okay, so we need to make this true. This needs to be 0 to make that true to equal 0. So -6 plus the +2 is a -4, meaning that that has to be a +4. There's one of them, so 4 times 1 is going to give us 4, and that makes it true. So we need to now just make sure to divide by our subscripts, which is going to be 3 right there, giving us the -2 there. Not changing anything on these because dividing by 1 is not going to, so +4 on that, and then we have our oxidation numbers. Okay, so that's how you do it every time. If you don't know your polys or your charges, then you're going to be in trouble. So you need to study over the polys that we've been going over. You need to make sure you know the charges, make sure you can identify them. I'll do one more really quick. That's just one more aspect of this, and then we're going to move on to the equations. And I'll do a couple of the ones that are on the worksheet. So really quick, I do want to mention or go over this type right here. So let's go with titanium here, and let's just go with. Okay, so try this on your own really quick. Pause it. Try to do that, and then we'll work it together. So titanium, our transition metal, and perchlorate. So another poly perchlorate here. So you need to know what the charge of the perchlorate is. It is going to be just a -1. It's a 1 negative charge on them. But the difference in this example here is going to be we have 3 of them. So we have to account for that. So we bring these down and separate them for a second. ClO4, 3. The big thing with this is you got to remember something. Yeah, each one of these perchlorates is going to have that -1 charge, but we have 3 of them. Since we have 3 of them, it still needs to be balanced by that titanium. That titanium still needs to balance it because there's no charge there. Okay, so just remember what this means. Remember what that means. That equates to ClO4 plus ClO4 plus ClO4 plus ClO4. Well, actually, that's 4 of them. Take one off. There we go. So that equates to 3, okay, because we have 3. That subscript's telling us that. All right, so that means that the overall charge there on that perchlorate and 3 of them that needs to be balanced is going to be a 3 negative charge. So all those added together is going to equal to that 3 negative charge. So we need to balance it. So what does that mean? That means that we need our titanium to be 3 plus. And that's it. And then we're balanced. That's it. So that's about the extent of what we're dealing with here with these transition metals and, assigning oxidation numbers. So as long as you're good on those things, you should be good to go for our exam tomorrow. So let's go ahead now and wrap this thing up since we know that's going to be a +3 on our titanium. Let's go through it. So everything get its own space. I think it's the easiest way to go ahead and distribute this into your atoms and your elements in there before you write it out. So we're distributing. So 3 times 1 is 3. So that's going to be Cl3. All right. Then we have 4 times 3, which of course is 12. So I don't know why I put a 10. So O12. Okay, so everything's out now. No charge, so we're equating this to 0. All right, we know this is plus 3, so we can bring that down 3 times 1 since there's 1. We got that. That's handled. Now we have our oxygen. So what are we doing with this? Well, we still know that that's a -2, and that's going to be 24. So 12 times -2. So we -2 times that 12 is going to give us that -24. We need to get this side over to 0. So we have 3 chlorines, and we need to make up, we got to take this, if we have -24 plus a +3 is going to be -21. So we need to get these chlorines to make up the difference to get our side to 0 over here from a -21. And what can you multiply by 3 to get 21? Of course, that would be 7. So if we have 7, and that's a positive, times 3 is that's going to equate to 21. So 21 plus 3 is 24. That's a positive 24. Add it to the -24, and we're now zeroed out. So don't forget, again, we need to divide by our subscript up here. So that's going to be -2 for our oxygen right there. We need to divide by 3 right there, which of course is going to be a +7, and then we're done. And then that's our. If you did this, you got it correct. You're in a good spot. Okay, that's the basic concepts behind these oxidation numbers with the transition metals. Okay, so. If you have any questions, let me know. But in the meantime, let's switch over to our redox and do a couple of those equations that are on that review worksheet that I posted. Okay. All right, let's go with 3. All right, so here's our equation. Again, I would encourage you to pause and try to work this out on your own before you see me do it here. So always, let's get the easiest ones out of the way. Assign our oxidation numbers, the ones that are unbonded, 0. So that's the only one that's going to be in there. And from that point, we can just pick one and kind of go to assign oxidation numbers. So let's just start right here and make our way across. I will show the work on this one right here. And in fact, I'll tell you what, I'll show the work on every single one of these in this equation. In another, I think I may maybe do another 2, and I'm not going to do it every time because I think that we're kind of beyond that point of having to show all the work out. But I'll do it on this one real quick, and then we'll see how things go in the next ones. So give everybody their space here on my this compound. So hydrogen plus nitrogen plus oxygen O3, no charge. So we're equating that to 0. All right. We know that's going to be -2 times 3. That's -6. We know that's going to be +1. So 1 times 1 is going to be 1. We have to get this to 0. -6 plus 1 is -5, giving my nitrogen that +5. So that equates out. We're going to divide again by 3, giving that -2. That's by 1, and that's by 1, giving me +5 and +1. Okay. Again, over here, now we have that transition metal coming in. We've got our copper. So in that case, let's look at it. Let's separate them out. So my copper and my nitrate here. So you have to recognize that as nitrate and recognize that has a 1 negative charge. So there are 2 of them. That's going to be a 2 negative overall. We have to balance. So 2 negative, obviously balancing that would be 2 positive. So we already know that's going to be a +2 oxidation on that copper. All right. So now let's go ahead and work out the rest of this. So copper plus nitrogen, 2 times 1 is 2, so that's N2. 2 times 3 is 6, so that's O6. And this is equating to 0. There's no charge there. So quickly get this thing done. All right, -2. So -2 times 6 is a -12. Our copper we already know is +2, so we can go ahead and do that. There's one of them, so that's going to be a 2. -12 plus a +2, we're at -10. We got to get to 0. So there are 2. So what can we multiply by 2 to get to 10? Of course, that's 5. So 5 times 2, since there's 2 atoms, is 10. And now we are worked out. We're ready to roll. So last thing, go ahead and divide by your subscript. That's going to give me a -2. That right there is going to give me a +5. And we're set up. We're ready to roll. Okay, so last two real quick. This one's really simple, so I'm not going to show the work on that. That's really, we already know that that's going to be a -2, and it's a 1-to-1 ratio, so that's going to make that, that nitrogen a +2 right there. All right, for H2O, I will show you really quick. So we have H2 plus O is going to equate to 0. There's no charge. So do this. All right, -2 times 1 is -2. We know that's +1, so 1 times 2, of course, is 2, and that will equate out. So we divide that by 2 to get us our +1 on hydrogen and -2 on oxygen. All right, we're set up with all of our oxidation numbers. So next thing we'll do is we'll go ahead and see what's been oxidized and what's been reduced. Again, I know some of you guys are struggling a little bit with this, connecting the concept of oxidation is loss of electrons, and loss of electrons is going to cause that number, that oxidation number, to go up. So we're dealing with things going up, things going down. How are we doing this? Look, you've got to root yourself in the fundamental concept of an electron and its charge. It's a negative charge. All right, so if you're losing a negative charge, you're becoming more positive. And if you are gaining electrons, you are gaining that negative charge, then your oxidation number is going to go down. So you've got to know that. You got to solidify that in your mind and bridge that gap and think about it every time. But the more reps you get on these kind of problems right here, the easier it's going to be. Just commit yourself to knowing that. So starting with oxidation, that would be an increase in our oxidation number. So we start with copper right here. We have copper at 0, and we're going to check it over here. We see that it went up to +2. So it went up. All right, that means it has lost electrons. It has lost electrons. And so just like I was saying the other day, and I use this example in class, and I'll do it again. Remember, charges come from the interaction between protons and electrons. If I have 1, 2, 3, 4 protons, and I have 4 electrons, then I have no charge. Okay, I'm neutral, like this right here. It's neutral, right? Well, if I go to a +2 charge, what does that mean? That means that I have 2 more protons than I do electrons in this model. So I take these electrons away, and what do I have left? I mean, these 2 still cancel, but I have 2 left over. So oxidation, loss of electrons, that's what I've done. I've just taken those electrons out, and I have that unbalanced ratio of protons to electrons. And now I have this +2 charge, which is what oxidation is that loss of electrons. So that's on a very fundamental level, but that's essentially what we're still doing. We're still doing that. So here we go. There's my oxidation. All right. And again, I'm a big fan of, when we're talking about our agents, there's my oxidation agent and my reduction agent. I'm a big fan of just go ahead and do it. You just identified what's been being oxidized, and that is your reducing agent. So go ahead and put it on there. So it's copper right here. It's not bonded to anything, so we don't have to put anything else. So we just put our copper in there. So now we're done with our reducing agent. Now let's find our element that's being reduced. So let's start with hydrogen. So +1 there. +1 there, that's a no-go, so we're not worried about hydrogen. Nitrogen +5 to +5 right there, so that's no good. But just be careful, because there are more elements over there, and in this case, there are multiple spots where nitrogen exists. So nitrogen at +5 there going to a +2 that is a gain of electrons because your charge has dropped. You gain negative charge, so it goes down. So here we go. That's our reduction right there. So we're going to label that as our reduction. All right. And since that is our reduction, that is our oxidizing agent. So we put this whole compound in there. So NO3. All right. So now we're set up with our agents. Those are done. Just do a quick check. Make sure you go through every element and make sure nothing else is, going to be a problem here. And all we have left is oxygen, and that's going to be -2, -2, -2, -2. So we're good. We're done with all that. Okay. Now let's get to our half reactions here. Look, I've explained it several times. Again, when it comes to these half reactions, we're not dealing with the coefficients because we aren't balancing. We're not there. We're not at that point right now. All we're doing with these half reactions is we are just showing the element and what's happening with the electrons, okay? If we were to be balancing the redox using half reactions, then it would look a little bit different, but we're not doing that. So all we're doing here is just showing a basic simplistic view of our element and what is happening with its charge and the electrons. That's all. That's all we're doing here. So oxidation. So we'll start there. We have copper right here. So I'm going to show you guys an alternative route to do this as well. I'm going to show you two ways, but the first way is the normal way I've been doing it. So I have copper right here. It has a no charge, so I'm not going to put a charge on there. I'm going to go ahead and bring it over. Now I have the copper 2+, so it's going to have a 2+ charge over on this side. So if it went from neutral to 2+, that means that it's lost 2 electrons. So again, electrons are going to be lost there, and we're going to put 2. So again, on the product side, it's gone. It's out of here. We're not combining these. These are combined over here on the reactant side. Over here, it's showing that they have separated. They're separate. So then we're going to go on to our reduction really fast. So that's going to be a nitrogen, and we have a 5+ charge right there. So on this side, we are bringing in some electrons. So at this point, we go, all right, we're going to have electrons here. It depends on how many. So let's look at the difference in oxidation number. Yeah, +5 to a +2. It's a difference of 3. Okay, so we are going to add in 3 electrons there. And then the result of the product of that is going to be nitrogen with that 2+ charge over on our product side. Okay, that's the way I've been doing it. But let me, I have a different method you can kind of use. It's just a different way to do it, and it's kind of resonated with a few people. So maybe it will help you out if you still are kind of confused. I see a lot of students are still confused about which side do I put my electrons on with these halves, and what am I doing with charges and so on and so forth. So let me just do this again another way, and this is just another way to do it. Maybe it'll help you. So preset it. Doesn't matter what you're doing. If you're doing a redox reaction, you can set it up like this, and then just go ahead and preset your the template of your equation here. So that, of course, is going to include your yield sign. All right, so you can put your 2 yield signs in here. You know the electrons are going to be on the product side or the right side of your oxidation, so you can go ahead and give yourself a little space and put that right there. Now leave yourself a little space there because we may need to put a number in there. All right, you know that on the reducing side, the electrons are going to be over here. So I'm going to go ahead and put plus electron there, and I'm going to leave myself space in case I need to put a number. Okay, so now you're preset. This is our template. All we need to do is put in our elements, and we're done. So at this stage, we can just go ahead and put our elements in. Oxidize. What's being oxidized? Well, copper is. Does it have a charge? No. Okay, then just bring down copper. All right, bring it over, shoot, over here to copper 2+. Okay, bring it straight down. So now we have Cu 2+. All right, the only thing left we have to do is see if we need to put a number in here. And in that case, we need to find the difference in the numbers between 0 and 2. So there is, if you go to from 0 to 2, that's a difference of 2. So just put the 2 right there, and then you're done. Okay, so if you prefer to do it like that, then go for it, if it helps you. So now the same kind of technique with our reduction. We're seeing what's getting reduced here. We see that it is nitrogen at +5 and then over here at +2. So bring the nitrogen down with a charge of that 5+. All right, Then over here, we bring that straight down, and that's going to be nitrogen 2 plus. And what's the difference between these two numbers? 5 and 2 is 3. The difference is 3, then put the 3 right there in front of the electron, and we're done. That's it. So I know I took a lot of time on this equation here. I know a couple classes got to it, a couple didn't. But that's it, guys. That's the technique. That's what you got to do every time. You do that every time. The same thing. Bring consistency into your method of solving these, and then you won't have any deviation, and it'll increase your accuracy. So here it is. Let's see what time it is. Let's do at least one more. See if we have time for two. All right, let's see. Let's grab another one here. All right, let's try this one. Okay. All right. So since we are kind of running a little short on time, if you still are struggling with some of the oxidation numbers, I got another video that I posted in Schoology back there, back maybe last week or something like that. So go check that out because I need to kind of run through the oxidation numbers a little faster. I will take a little time on the transition metal just because that's a little newer for us. But pause the video, try to knock this out on your own, and then we'll go through it together. Okay, copper and sulfur. So in this case, we look at copper and sulfur. Now, we don't have that rule necessarily that we've been going over for sulfur per se, but just look at the group that sulfur is in, and that will help you kind of solve this. So let's bring it, I'll just bring it over here for a second so we can kind of look at it here. So Cu2 plus S is going to be equal to 0 because there's no charge on it. All right, so what we just need to do here is we need to look, okay, we know oxygen is always -2, and what's the reasoning behind that? Well, oxygen has 6 valence electrons and wants to get to the 8, and so on and so forth. So, so do some of these other elements that are in the same group of 16. So sulfur being right below oxygen also can be that -2 because it also has 6 valence electrons and it also wants 8. So in this case right here, that's where we're going with this, okay? We see that if we had a 2 negative charge on that, that would fit fine with this copper because copper, of course, being a metal, wants to give up its electrons anyway. So when we put that -2 and we go by 1, then that, of course, is going to give us -2. So we need to balance this. So this needs to equate to +2. There are 2 of them. So that would be the oxidation state here is going to be +1 for our copper. So 1 times 2 is going to equal 2. And that's how you would work that, okay? I'm not really planning on, going super hardcore, on you guys when it comes to these elements on the exam, but that's just basic reasoning that I would like you guys to have when it comes to something like oxygen that we are constantly seeing in these redox reactions and understanding these periodic trends that we have learned throughout the year. That's the reason why we've been you went through that whole first quarter learning about these periodic trends and what these elements what their behaviors are and what their tendencies are and the trends that go across the periodic table up and down these groups and across the periods. So sulfur being right there, we're going to go 2 negative on that, and that is going to give us of course, divide that by 2. So that is going to give us a +1 charge on our copper and then a -2 on our sulfur there. Okay, let's go ahead and put that up there. So +1, or yeah, that's right, -2. Okay, so O2, 0, 0. Again, we see a little bit of a switch here. So now my oxygen is going to be that -2. -2 times 2 is -4. Okay, so I'm going to put that -2 right there. So -4 needs to be balanced by 1 sulfur, so that's going to put that at +4. Okay, so now we're all set and ready to roll. All right, so here we go. Let's look at it. First thing, copper. So I'm going to go copper +1 and see that now I have 0. So that is not being oxidized. We're looking for oxidation first, then we'll go to reduction. So that's no good. Sulfur going from -2 all the way over here to -4. So 100% that's being oxidized. That's going to be being oxidized pretty hard. So we're going over there. Okay. Actually, I don't know why I put that on the bottom. Let's go back up top. All right. Oxidized. So now what is being reduced? All right. So, well, also actually, when we continue going down, we see that right here, this oxygen is at 0. Okay. And then we come over here and compare it to this -2. That's going to be a reduction right here. And then we have a reduction of our copper at +1 going to 0 right there as well. So we have multiples. So let's go ahead and do it. Let's knock it out. So let's start over here with copper, negative or +1 to a -2, or excuse me, to a 0. All right, reduced. Okay, so now, oh, also let's go ahead and throw our agents over there. I'm getting ahead of myself. So our sulfur right here is going to be being oxidized. So of course, for our agents, that's going to be our reducing agent. We're putting the whole thing. So Cu2S is our reducing agent. All right. Also, for our first reduction here, we have copper going right here. So that will give us our oxidizing agent of the same thing. All right, and you could break that down further, obviously, by each element. All right, next reduction we see is going to be the 0 to the -2 right there. All right, so that will be our next reduction. Well, I don't want to go through that. Let me just piggyback off of it right here, going over. Okay, so for that, since that is also being reduced, that's going to be our oxidizing here. So we're going to go O2. Okay, so, and by the way, I didn't realize that this had 2 when I pulled it up. I'm probably not going to put something with like this on the exam for 2, but let's just do it. We're already doing it, so might as well just go ahead and knock it out. All right, so for our half reactions here, oxidation is going to be a sulfur with a -2 charge, so 2 negative. All right, and put it over here, and we're going to end up at a 4 positive, so sulfur at 4 plus. So the difference in those numbers is going to be 6. There's a 6 difference, so we're going to add 6 electrons on there. Okay. Now we'll look at our first reduction. All right. So our first reduction is going to be our copper. So we're going to go Cu plus. All right. Then the difference in these numbers between +1 and 0 is going to be 1. So we're going to add 1 electron, which is going to give us Cu straight up, no charge. Our next reduction is going to be a oxygen. So oxygen going from neutral state there. All right, and then we are going to be adding, going from central or neutral, excuse me, to -2. So we're going to be adding 2 electrons. And of course, that's going to give us at the end 2 negative. Okay. All right. So there's all of our half reactions, agents, and oxidation and reductions. Again, I probably, yeah, I know for a fact I'm not going to give you something with multiples like that. And okay, so I'm pretty much running out of time here, guys. So let's see. I got 5 minutes. So let's see. Let's try to do one more really fast. I'm going to kind of go quick on this next one because I don't really have much time. So once I put it up here, pause the video. All right, let's see. G plus 2. GNO3 2. All right, so we got like 4 or 5 minutes at most. So pause video, do it, or this, I think this is like number 10 on the worksheet. So try to knock it out, and then let's roll with this. All right, so let's go ahead and get our zeros knocked out on our lone elements that aren't bonded. All right, we have our first transition, but in our rules, we kind of already know that aluminum is going to be +3. All right, and plus nitrate is -1. There's 3 of them, so that's going to give us a -3 overall on that poly. So now let's quickly do the math. So we have 2 now. We know that's going to be -2. So 3 times 3 is 9. 9 times 2 is 18. So we have -18. And then +3 on that is going to be -15. 3 times 1. So what goes into 15 3 times is 5. So we're going to go +5 on that. All right. Over here, we have, again, it matches up, although this right here, of course, is an alkaline earth metal, and we know it's going to have a +2 charge, so we'll just go ahead and do that. But it still matches up with the nitrate being 2 of them, 2 negative charge. So we have 3 times 2 is 6. We know that's going to be -2. 3 times 2 is 6. 6 times 2 is -12. -12 plus the 2 is -10, and we have 2 nitrogens there, so again, +5. All right, and then we have 0. All right, sweet. So let's go ahead and label our oxidation and our reductions. So magnesium here will be 0, and it's going to go to +2. That's definitely being oxidized. So we're going to label that as our oxidation, and go ahead and throw that as our reducing agent. So that'll be our magnesium right there. All right, so my aluminum here goes from +3 to 0. That is being reduced. So I'll go ahead and label that as my reduction. So, all right. So then we'll go ahead and throw that as our oxidizing agent right there. So we're putting the whole compound, that is Al, NO3. All right, there's our oxidizing agent. All right, let's double check everything else is the same. Nitrogen, nitrogen, good. Oxygen, good. So we're good. We're golden. All right, sweet. So oxygen here, half reaction. This magnesium is being oxidized, so we're going to go ahead and put magnesium, and that is no charge, so we're good there. We'll throw our yield sign. What are we ending at? It's +2, so magnesium, that 2 plus. 0 to 2, that's a difference of 2, so we're going to throw that 2 electrons on there. Boom, done. All right, reduction. So aluminum, we're starting off with that 3 plus charge. All right. So where are we ending? We're ending at neutral, so that's a difference of 3 to 0 is a difference of 3, so we're going to add those 3 electrons there, and then we end at neutral. Done. Sweet. Got it done before the bell. So there it is, guys. You can do this. There is no reason you can't. Commit yourself to doing it, putting in the time. If you're watching this video right now, you're already there. You're already committing your off time to learning this, and just enhancing your understanding of this. So you'll do well on the exam tomorrow. Don't forget about your polys. Study your polys. Study your polys. Go over some general trends of what a redox reaction is. It is, the reaction highlighted by movement of electrons, knowing that an element is losing and somebody is gaining from one substance to another, these electrons, right? those real world applications, photosynthesis, batteries, things that we talked about in class. What is oxidation, loss of electrons? What is reduction, gain of electrons? How do the charges change? So as you're being oxidized, your oxidation charge goes up. As you're being reduced, it goes down. All of these things, just keep those in mind and keep grinding on it. You got it. You can do it. Put in the time. If you have any questions, of course, reach out, guys. I'll have my computer tonight to a certain time at least. But let me know. Hope you guys this worked for you and you learned. And 100 tomorrow on the exam. You got it.